In this video, we're going to talk about a few properties of parallelograms. Very basic, I won't do any proofs at all. If a convex quadrilateral has opposite sides congruent, then it is a parallelogram. Now, that's not the definition of a parallelogram, although it could be used as the definition, because remember the definition talked about the opposite sides being parallel. So these two are parallel, these two are parallel. Well, this is saying if opposite sides have the same length, then we have a parallelogram. Part B, if a convex quadrilateral has a pair of sides that are both congruent and parallel, then it is a parallelogram. These could actually be used as alternate definitions for a parallelogram. So in this case, we'll note that in the picture anyways, it has a pair of sides that are both congruent. That would mean they're both congruent. And then if you, in addition, DC is parallel to AB, then we know it's a parallelogram. These two sides have the same length and they're parallel. And likewise with these two, same length and parallel. All right, let's go to C. The diagonals of a convex quadrilateral bisect each other. That means it cuts each one into two equal pieces, equal lengths. If and only if the quadrilateral is, you guessed it, a parallelogram. And let's go ahead and draw that. If the diagonals bisect each other, then it is a parallelogram. So what that's saying is that this length and this length are equal, and this length and this length are equal. That's the definition of bisecting a line segment into two equal length pieces. D. A parallelogram is a rhombus if and only if its diagonals are, well, this one's going to be perpendicular. Now, this I did not quite draw as a rhombus. I kept all these parallelograms the same shape, basically. Remember what a rhombus requires. It requires equal length sides. So it's not going to work in this picture, but if we took the diagonals, I'll pretend it is. It's close, you know. The top side and bottom side are a little bit longer than the left and right sides. If this were a right angle, which it's not quite based on this picture, if it were a 90-degree angle right here, which would mean all of these would be 90-degree angles, then it would be a rhombus. Part E. A parallelogram is a rectangle if and only if its diagonals are what? Well, this is clearly not a rectangle here. But what do you think? Which one would have to be bigger in order for this to be a rectangle? Which diagonal? Well, neither one. They must be congruent. And let's show that with a rectangle. Oops. All right, that's not a great rectangle. But assuming that is a rectangle, this length, this diagonal, is the same length as this diagonal. If the diagonals have the same length, you've got yourself a rectangle. All right, now let's get really specific in this one. A parallelogram is a square if and only if its diagonals are both what? What do you think the two properties would have to be? be a square? Well, they definitely have to be the same length, so they have to be congruent. Let's see if we draw a picture of a square and the diagonals. They have to be the same length, the diagonals do, and where they intersect has to be a 90-degree angle. If you have both of those, if the diagonals are equal length and they intersect at 90-degree angles, which means perpendicular, that means you have yourself a square.